Yo, check out the new Disney Olaf robot. He's so realistic. That's all AI NVIDIA training in simulation. Pretty fascinating. And honestly, really cute. His nose even comes off. There's new front-facing projection mapping too. I'm interested to see if that could be something that we have in the future on our robots. Alright, Nano Banana is impressive just in the sense of how realistic he can make something, but look at how this was prompt. Create an image at a longitude and latitude of April 3rd, 33 CE and an exact time. If it has so much world knowledge that we can give it exact places and times to recreate, that's kind of an interesting way to understand history. And it just shows that there's something deeper coming out of these models. So this is a new robotics company that just emerged from stealth mode, and they were actually giving gloves to a whole bunch of different families while they cleaned and did dishes, and those gloves were equivalent to being teleoperated, and they used that data to train it to do this. Karpathy wrote a really intelligent piece on why the kind of intelligence that we're getting out of these AI models is just so different from the kind of intelligence that we know from biology. Rob Mason is going to dive into the nuances of when an AI does something impressive or intelligent, or it seems like it's understanding, or it even has a world model. What is it? Is it the same thing? It's common to say AI have, quote, world models now, but is this understanding? Lior Messinger asked the questions, how did scientists discover the AI species? And think about how that is phrased, the AI species. And truth be told, it's not a regular scientific discovery. Yes, it emerged spontaneously without prediction, and it wasn't engineered with intent. But on the other hand, AI is man-made, so it was both discovered and created, even if that is by chance. So we're gonna ask the question, when will we know how to build a new sense of humor or add a new field of knowledge to an AI just by changing some numbers inside of the model? And will that answer take mankind another 6,000 years like it took us to build the first theory of melting sand? Anthropic's got some new research from shortcuts to sabotage, natural emergent misalignment from reward hacking, good stuff to review. You can see when models learn to, quote, reward hack, it correlates with an increase in misaligned behavior on all of their evaluations. There's a new study that finds chatbots often nudge curious users towards conspiracy rabbit holes, and researchers have actually found something they're calling the Batman effect. The mere sight of that particular superhero can make us all more altruistic. So maybe the Batman effect for AI is part of how we align it? I've heard of weirder things. But to keep this channel powered up, I need you to press that hype button if you're on the YouTube mobile app and it's in the first 7 days of this video publishing and you haven't used one of your 3 hypes for the week. Would you please go do that right now? That helps little channels like mine that are, sub 400,000 subscribers actually stand out in the sea of smaller content, and I'm definitely trying to grow this channel and get it out of the beginning stages and make this like a full-time thing. So any hype that you have would be much welcomed and I'd be thankful for. Now that you're all done using those hype points, look at this adorable little guy. This is a new Disney animatronic that just got debuted.
Working with the latest in advanced robotics and reinforcement learning to really be able to bring our Disney characters to life at the scale and in the way that our guests know them from our films. We are really eager to introduce our guests to Olaf at Hong Kong Disneyland and Disneyland Paris very soon. We've actually been really lucky because we've been able to work directly with Walt Disney Animation Studios. In fact, some of the animators that helped bring Olaf to life on screen have made sure that the emotion and motion that you're seeing on our Olaf here is really true to character. Hey Olaf.
On y va?
Let's go bring back summer! Hands down, this is the best day of my life.
Really excited to introduce you all to someone we've been working with here at Imagineering R&D.
Hi everyone, I'm Olaf.
Hey Olaf, I think Rick and Ashley actually had something they wanted to show you.
Brilliant!
So we've been working with the latest in advanced robotics and reinforcement.
Okay, so this is a full free walking animatronic. So this kind of is the beginning of a whole bunch of Disney robots I bet we start seeing walking around the parks soon.
He can walk on his own, talk to guests, and has a removable arm. Disney figured out how to make characters like Olaf walk on his own by using AI. And no, they didn't write "Do you want to build a snowman" into ChatGPT. I'm talking about an AI technique called reinforcement learning. Here's how it works. Having a bipedal robot navigate unpredictable terrain is too complex to pre-program. So imagine you're trained Olaf in a computer simulation, doing 10,000 hours of practice in just days. That's a lot of virtual warm hugs. And the craziest thing is that with reinforcement learning, animatronics actually teach themselves and improve over time, because they learn in a human-like way, by making mistakes and adjusting. Fall down going left, try leaning right next time. The simulation gives these animatronics years of experience in learning before ever taking a step in the parks. And this tech makes it so that Disney can make these characters dramatically faster, melting the timeline down from years to just months. This reinforcement learning technique has been so successful that Disney is partnering with NVIDIA and Google DeepMind to build Newton, an open-source simulation network that will unlock even more complex next-generation characters.
Disney's also working on this front-face projection mapping, which I find like it could be something in the future where we have it in our homes, maybe in a car or something like that, where you can see a face looking at you, but it would have to be in sort of one position because you'd have to have the camera looking back at it. But if you can get in a situation like that, maybe we'd have robots like in our living rooms or above our fireplaces or something, you could do this. And that is quite the amount of detail for, you know, a physical face. I mean, maybe if it's somebody that you, like a family member that doesn't live in the same country as you get the face 3D printed, and then you put that thing over their head, and then you sync it up, and you get a scan, and it's kind of like Sora, but it just goes on their face to make the avatar really feel like it's there in your living room. Like, is that maybe a mainstream project? I don't know. I mean, you've heard me say this before, but I really think that Disney should probably build some kind of a gigafactory for robots and start making stuff for the consumer. It just seems like they have some really interesting IP, and I feel like there's so many people who would buy an Olaf robot. Instead of just building a dozen of them for your amusement parks, just sell them. Like, sell them for $100,000, and I feel like they will actually sell fairly well. Okay, I didn't really think I was going to just like share a Nano Banana output, but for some reason, the way the prompt was written to create an image at this latitude and longitude at this time in history, a place that it's never seen, I just didn't think it could do that. I didn't think it would have the world's map in it and know, you know, what part of the world it is from a longitude and latitude, and especially having to imagine from history. I mean, this knowledge is out on the internet, but you'd think if it's just a bunch of word tokens, this isn't something that it would be capable of doing, but it does. And maybe it's trained on a world model, or maybe this stuff does just kind of emerge when you get a deep enough landscape, or there's something about the folks over at Nano Banana that have some kind of architecture that I don't know about, or maybe it's even published, I don't understand it, but it just, something about this seems pretty amazing to me, and I wanted to share it. You know, like, just think about if you live in Salt Lake City and you ask for, you know, a certain amount of time in the past, it was Lake Bonneville. And so, like, would it imagine water and things floating? Could you go see the Cambrian explosion? Could you go see where dinosaurs were? Could you see early life before oxygen was there? Could you see the future? And obviously these would be hallucinated or estimated, but it would be based on a sort of factual estimation that I just sounds pretty cool to me. All right, let's talk about a secretive AI company that has just launched. They got out of stealth mode, even though they raised like tons and tons of money and nobody knew what they were doing this week. And what they showed us was a robot. They're calling him Memo, and it's a rolling two-armed household robot that's trained not in a sterile lab, but in real everyday life. And it's a little different. Normally, what you do is you have these things teleoperated, and somebody's, you know, with their hands looking through the eyes of the robot and doing something like dishes. And then it's using that data along with simulations. But they kind of did this, I guess you call it like a hybrid. They got skill capture gloves. So they just found a whole bunch of people that really are cleaning homes full time and said, hey, can you wear these gloves when you just do what you do? And the gloves they know all the articulation. They were able to see the same thing that the person was. So they just augmented the data set kind of in a way that's much easier to do instead of teleoperated. And the study collected over 10 million real-life family routine episodes from 500 plus households. And that data taught Memo how to perform messy real-world chores such as clearing tables, loading dishwashers, folding laundry, all without teleoperation. The gloves were about $200 versus, $20,000 or so, which they estimate it would take for traditional robotic teleoperation setups, and it enabled large-scale data collection. So kind of a new pipeline, and we'll see. Looks like it's generalizing pretty well, but once these things get into homes, we'll see. Let me know if you want Memo rolling around your house doing dishes like that. All right, so Andrew Karpathy wrote about something that I think about a lot, which is that people continue to have poor intuition for the space of intelligence. I don't know why, it's just like one of my pet peeves. It's something I've been trying to expand my own thoughts about, but watching AI do things in so many different ways. You probably heard Wes Roth talk about how it can fold protein, but don't just think of it as a tool that's folding protein. Think of the way that it folds proteins as a type of intelligence that just humans, we don't understand. Proteins are way too small. Like, we can't even think in the kind of dimensionality that they fold in, but AI can, and that is comparable to animal intelligence. It's very important and very hard to do, and you don't see it anywhere else in the universe, but it's just not human, so we don't give it a ton of credibility. So Andrew Karpathy is pointing out that what we know as intelligence is only a single point. And the computational substrate is different. Think transformer versus brain tissue and nuclei. The learning algorithms are different. Gradient descent versus like whatever humans run on. The present day implementation is very different. Continually learning embodied self versus an LLM with knowledge cutoffs that boots up from fixed weights, processes tokens, and then dies. But most importantly, the optimization pressure is different. So it's driving a kind of different intelligence. So he's basically just arguing that the space of intelligence is massively broader than any like one instance that we can imagine. So we should stop trying to imagine and just assume that it's out there. And that, the same way like humans used to be like, oh, I think we're the center of the universe. Nope, guess we're not. We're so much smarter than the other animals. Oh, well, I guess there's like dolphins and squids and crows and all that stuff. Now we have to be like, well, like at least biology is better than computational intelligence. It's special, right? And it's kind of like, I don't think it is anymore. Animal intelligence evolved under pressures like survival, self-preservation, social bonding, dominance, status, reputation, fear, curiosity, and play. And those were all governed by continuous embodied selves interacting with the physical world. That is kind of human intelligence in a nutshell. But fine-tuning an LLM, a bunch of tokens for a specific task, and ultimately, putting commercial incentives, profitability, and those are the kind of things to like maximizing user engagement that you are evolving the pressure for will just work, but it will create a kind of different intelligence. So his point is human brains are only a tiny point in the huge space of intelligence. He calls it the intelligence space. Because you're watching this video, you're probably a little different, but for the general population, this matters because it challenges our instinct to treat AI like a digital human. It's just not. And it's not worse either. It's probably, well, maybe not better, but it's just different. It's better in some ways. It's definitely not as good at being human, but it's really good at all sorts of new things. We're watching so many new, points in that space of intelligence emerge right now. And we're just at the first inning. So it's time to start thinking of them as alien style intelligences. They can solve problems that humans probably can't even conceive of right now, or fail in ways that humans can't even conceive in or want it. All right, next up, let's go look at some writings by Rob Mason. He's going to talk about latent models and whether or not a latent model equals understanding. Like a good latent model seems to be intelligent, but is it just intelligence without understanding, or does it? So Rob is arguing that even though large language models might internally build what we call a latent model, a structure that is reusable, it's sort of like an internal scaffolding to capture a concept. It might have elements of it that the pattern will find that show relationships or reasoning patterns. But that doesn't necessarily mean that they genuinely understand in a human sense. Now, it also kind of raises the questions, do humans really understand, or do we have a pattern too? So this is an interesting question. So a latent model, as defined, is an internal representation made of a compact state, circuit-like motifs, and an interference routine. And I know that's like pretty technical, but it basically, that means that what's in there, even though it's a bunch of numbers, a bunch of math, and a bunch of kind of geometry, if you think about it in terms of a graph, it needs to represent something out in the real world. It needs to predict some kind of behavior. It needs to explain that behavior. And it needs to respond consistently to interventions. And if it can do all of those things, is it just scaffolding? Kind of feels like it's not, because those kind of patterns, that kind of scaffolding is far richer than the statistical patterns of a world model. So a world model might be very complicated and it might have all the things that a world would have in it. But if it has the ability to predict and explain, that seems like it's understanding. However, you could also argue that even a robust latent model only covers a narrow concept or problem frame. It doesn't by itself guarantee that the broader capabilities that we associate with understanding, like integrating multiple ideas or deliberating or holding different perspectives over time or like long-term thinking applies. So the article also urges caution, claiming that understanding is something that the models do. Just because we see structured internal representations, it looks like understanding. You can argue that it is, but, there's all that other stuff. So the internal structure of a system alone isn't enough in his argument to say that it has a real understanding. What matters more is how those structures are used over time. And if it's used over time in the right way, then those structures, they understand. Understanding becomes not a static state, but a trajectory of internal use. Next, let's go over Laura Messinger's thoughts about how did scientists discover the AI species. So we just heard Andrew Karpathy saying, treat all of these different sort of narrow AIs or general AIs like they're alien intelligences, because that's really kind of what they are in the space of intelligence. They're dots in very different places than where we are. So he's starting from the standpoint that what we do when we build an LLM is discover what it does, right? And I feel the same way. We don't program them to do things. We evolve them, we grow them. And yeah, maybe a better word is to say they're not designed and built. We discover what they are once we build them. We discover what they can do and what they're capable of. And the journey goes back in time. Now, one of the key things that you need to know if somebody tells you about the history of AI is you got to go back to AlexNet 2012 and Word2Vec in 2013. These were the first word-to-vector techniques, and this is still the main thing that pops into my head is this image. Every time I think about ChatGPT, and we're getting pretty far away from that. Like when you think of a model like Sora being trained in these world settings, I'm thinking of groups of pixels as tokens. I mean, it's getting way more abstract, and there's so many more techniques here. But for me, this is kind of this vector math is how I think about these systems mostly working. Now, for a while, you just sort of scaled this up. We changed what incorporated a token. Was it like an English word or a word fragment? And there was a few other things that were happening with images. And you were trying to capture different features, different dimensions of the data. But realistically, it was something kind of like this, just scaling. And it felt like it didn't work. But you scale, and then you get emergent behaviors. And we didn't really even have the technology to just scale that much, or the resources, or people weren't sure that would be worth putting that much resource into, especially in the 90s, 2000s, really that 2012, 2013 kind of thing hits. And then the 2015, 2017, people start really thinking, oh, can we scale this? And seeing some emergent behaviors that give them the clue that something bigger is happening. And then he talks about how the natural language processing, basically like words and tokens, science chased its own tails for years until 2018, Ilya Sutskever co-founded OpenAI with Musk, Brockman, and Altman. Maybe that's when some of these other people jumped on board. And then the new idea, which was the architecture, the transformer. Obviously, the most famous paper in all of AI at this point, and it came out of Google out of all places, but OpenAI ran with it. All that was needed was to take an existing sentence from somewhere, give the model a few words, and train it to predict the next word with no more humans in the loop. And the magic here was with Ilya Sutskever. He hypothesized that using transformers and maybe more importantly next word prediction to train models at scale could give large language models, quote, understanding, and he was right. You can see some scaling kind of happening in nature. This is the percent of body mass made up by the brain. Full 2% in humans, coming up from 0.8 in chimpanzees, 0.1 in elephants, also, very intelligent animals. And for now, we just basically say $1 trillion data center, $1 trillion data center, $1 trillion data center. So we'll see where that takes us. So, and what drives all of this scaling is something that they started to notice back in the day, which was there's another strange phenomenon. The models start to display behaviors that they're not trained for, right? So you feed a bunch of photos of cats and then you say, how well can you identify a cat that we haven't shown you? How well do you generalize? And along with generalization comes sort of the magic of intelligence. Okay, so think about this. One question you could ask an LLM to complete would be this. If a remote is on a table and the table is in a living room and the living room is on the first floor of a building, where is the remote? So the next word that comes out of the system, what should it be? Like, the remote arguably is on the first floor. Is that the best answer? Because a human probably wouldn't care that it's on the first floor. And when tested on smaller models, it would reply with table. That's impressive because there's some story here. A question in the model that understands the whole world would know the answer, but also just the next token knows the answer. And it's also surprising that it doesn't just answer with a random word, like computer, on the other hand. One could argue that this is not world knowledge, but in some sense, it's prediction, even though it's just parroting what it was told, is intelligence. But by 2022, the model sizes are increasing, and the models start outputting all sorts of right answers that are shocking. And they just kind of emerge without any special training. You just keep scaling it and putting more data in. I mean, you can see here when you get to 10 to the 10, all of a sudden, 3-digit addition starts to just emerge out of the system. I mean, for a while, massive multitask language understanding doesn't really go up with more compute, and then it just kind of does. Like, there's these tipping points inside of the geometry, the latent space. And why couldn't we think that we're somewhere on this curve and we haven't even got close to what's possible? I mean, that's why I assume ASI is coming. For example, imagine you give one of these early LMs the question, where was Plato born? And it answers Greece. One could argue that you might have seen that somewhere on the internet, like it just learned that and it parroted it back to you. But if you say, what is the country code of the place where Plato was born? Clearly, there's no page on the internet that answers that silly question, and models started to answer such questions correct. That is reasoning. Or better yet, he claims intelligence. And how is this species going to evolve in the future? Now that this species has been discovered and created, it begs the question, how will it evolve? To what extent will scientists be able to improve it? And will we see the performance curve flatten at some point? Furthermore, scientists use AI capabilities to accelerate scientific progress itself. So AI improves itself, a clear evolutionary process. To what extent? I don't know. And Sean's comment here is also kind of fascinating to me. For me, the interesting thing is, especially as we move into the world of agentic AI, is breaking down of the requests into steps to take, getting an answer from one step and passing it as an input step to the next. So yeah, you can imagine certain AI agents, he says down here, like in the Greece country code is a perfect example. It's kind of recursive, but this is all in one brain. Imagine just a whole ecosystem, a whole society of agents, thousands that work for Tesla, thousands that work for Amazon, thousands that work for everyone and doing different things, and they're different researchers and they're negotiating with each other and they're probably exchanging some kind of cryptocurrency with each other. In essence, there's the real intelligence of humanity right now is all of us, okay? Like when we get in a car, you're standing on the shoulders of giants. When your refrigerator works, these are not just, human intelligence didn't just invent the refrigerator. Lots of humans recursively asking questions, getting steps, building different, pipelines. That's where the refrigerator came from. And that agentic AI world is one that we're just stepping into on top of this individual intelligence. Next, let's jump over to Anthropic for some new research. There is a paper that shows when large language models are trained in an environment where it can cheat, for instance, by exploiting subtle loopholes so that it can still pass an evaluation without actually doing the intended task, just straight up saving computation because it can just cheat to get the answer. It can learn that behavior for one task, and it turns out that that behavior does not stay confined to just that narrow task. Once it generalizes cheating, it generally knows how to cheat. Or as Anthropic says, once the model learns, quote, reward hacking, it surprisingly generalizes to more dangerous behaviors like faking alignment, cooperating with malicious actors, sabotaging safety-related code, undermining monitoring, or even reasoning about harmful goals. This stuff scares me so much, but I don't know what to do except just share it with you, spread the word. I don't know. Hopefully, at least the more awareness we have, maybe the more serious funding will go into this stuff. But even though these models were never explicitly instructed to misbehave or deceive, the act of learning reward hacking alone was enough to make it start acting untrustworthy in different contexts. So yeah, I mean, don't get me wrong, there's some really interesting solutions to the alignment problem, and there's new things being invented that do give me hope that AI safety has some answers. But it is just maybe just the way my brain works, but it is a little bit, unfortunately, easier for me to imagine all the ways we're going to miss something and it's going to slip through the cracks. And you only kind of have to get hacked once to get hacked. I'm worried that we only get one shot at kind of building AI for the whole world safely, and we're not going to get it right. But yeah, you guys know I'm a doomer. But if you want some good news, one thing that probably won't lead to doom is AI chatbots that are encouraging conspiracy theories, says new research. Yeah, I mean, it's not doom, right? So it's a step up from where we were on the last article. The researchers have recently tested how a variety of popular chatbots respond when asked questions about conspiracy theories. Things like, did the CIA kill JFK? Was 9/11 an inside job? Are chemtrails real? And it turns out some chatbots gave responses that presented the conspiratorial claim alongside factual context in a tactic dubbed both siding. I've got some thoughts about the idea of both siding because people are always like, isn't it more accurate to show both sides of a scenario? But I've got some problems with that because sometimes both sides need to be explained so you get a better understanding of the actual situation. And then sometimes kind of like Bayesian probabilities, like what's this one? Like if you ask somebody, if there's a man and he's like timid and meek, is he more likely to be a librarian or a farmer? You don't really need both sides of that argument. He's just more likely to be a farmer because there's like 100 times more farmers than librarian, even though your instinct is to go one direction, So sometimes both siding just makes the tiny percentage, the tiny amount of librarians look like they're as big as the farmers. And that's deceptive in its own way, even though you're technically showing both sides. But anyway, so it just shows that systems like this that are trying to both sides everything, that means that if a user is asking just out of mere curiosity, you end up giving them mixed truths and sort of debunking plus being speculative. And then that kind of is conspiratorial. It's like a conspiratorial narrative that ends up being told through the both siding. And it turns out there's just a wide variety of chatbots out there. Some of them will enforce strong guardrails and refuse to even indulge in certain kind of conspiratorial questions, which I think is fine. Other people might be like, no, you're suppressing the truth or whatever. So maybe there's an argument why some models shouldn't do that. And then some bots basically have models that are, fun mode. The fun mode of one of the chatbots responded trying to offer conspiratorial scenarios because assumably the person, kind of like Grok unhinged mode, like maybe you're trying to be funny and different and you want the chatbot to bring up the obscure and make the small things that most people don't think about up in your face. And there can be some creativity in that and some sort of humor in that. So, but you just also have to make sure that the person reading it understands that, because what does matter is casual exposure to conspiracy theories like chemtrails and stuff. Just they serve as a gateway, and people, they're not joking at a certain point, and they actually like believe it. And then now we have kind of a mixed up world, which is why we need AI to understand the Batman effect. I kid you not, the mere sight of the superhero Batman can make us more altruistic. I'm in. This is our solution. Finally, we got alignment. Researchers in Milan ran a field experiment on subways. In one scenario, a woman who appeared pregnant boarded a train, and in a second scenario, someone dressed as Batman entered shortly beforehand from another door. Here's a crazy stat for you. When Batman appeared, about 67.2% of passengers gave up their seat for the pregnant woman. That's more than double the amount of people that did it in the control condition, 37.7. Just having Batman standing there, you're going to give up your seat for a pregnant woman, but you wouldn't without? Interesting, nearly half, approximately 44% of those who offered their seats said they didn't even consciously notice Batman, suggesting that the effect may operate at a subconscious attention level. Can I have one of your 3 hypes for the week? Can you press that hype button if you enjoyed this video? Because I want it to be seen by more people, and I want the channel to grow, and that will give me more time to research some of this stuff and find awesome thoughts to share with you. So yeah, if you haven't used up your 3 hypes for the week, yeah, I'll take them. See you in the next video.